Myself, Ketan Patel from Mahatma Gandhi Institute of Technical Education and Research Center, Navsari, Electrical Engineering Department. Subject is Testing and Commissioning of Electrical Equipments, 4th year, 8th semester. And chapter is Switch Gear and Protective Devices. Syllabus content: specifications, ratings and duties of circuit breaker, installation, commissioning, test, maintenance schedule, types and routine test, operation of assess, steps for line circuit breaker maintenance, locations of lightning arrestors with reason. Now, specifications, ratings and duties of circuit breaker. Uh, in specification of circuit breaker, in electrical system, for different equipments and fittings of IE standards are as follows. The standards: numbers of poles, devices, width, frame size, socket size, device depth, terminals capacity, lift terminal capacity, ring tongue, bus bar thickness, terminal screw, terminal torque, degree of protections, climatic conditions, ambient temperatures, storage operations, and mounting positions are required in standard specifications of mechanical sites. It also include the name of the manufacturers, types of circuit breakers like a bulk oil, minimum oil or air blast, number of plate, number of breaks in series per pole, total length of break per pole, types of main contacts, minimum clearance in air poles and live parts of earth, safety boundaries during the braking operations, head of oil above tank and number of tanks, etc. So these are the all are specifications of the circuit breakers. Now rating of the circuit breaker. Rating of the circuit breaker has to work in the following situations when it is connected in the power system. First is current has to be broken to isolate the faulty sections when fault occur. It has to made on when there is a fault in the circuits. Sometimes the circuit breaker has to be kept in the on state even in the conditions of fault. In such circumstance, the circuit breaker should be capable to withstand fault current for that much period. In following are the ratings of the circuit breakers on the basis of above requirements: the braking capacity and short time capacity of the rating of the and duties of the circuit breakers. First is braking capacity. Large fault current flow when the fault occurs in the circuits. This fault current should be broken through the contacts of the circuit breaker. The capability of the circuit breaker to break the fault current is known as braking capacity. For the given recovery voltage and specified power factor and given RRRV, the capacity of breaking the RMS value of current is known as the braking capacity. The braking capacity is of two types: the symmetrical braking capacity and the asymmetrical braking capacity. When the fault occurs, there is not only the alternating current but there is a DC component also. That means there is a asymmetry in the fault current. Braking capacity is expressed in MVA. If the rated braking current is I ampere and the rated voltage V volt, then the three-phase circuit breaker rated braking capacity equal to root 3 VI into 10 to minus 6 MVA. It is not logical to express the braking capacity in MVA as it is obtained by multiplications of the short circuit current and the rated voltage. While at short circuit, the voltage across the contact is much lower than the service voltage. Making capacity. Many times it happens so that the circuit breaker has to be closed in the short circuit conditions. Electromagnetic force are working on at this time and the circuit breakers has to become on in these situations. This force is proportional to the square of the instantaneous value of current at the time of closing. So for making capacity, peak value of current is taken instead of the RMS current. For this, peak current of the first cycle after closing of the contacts is taken because the maximum value of the fault current comes when there is a maximum asymmetry in the phase of the current breaker during the first cycle. Peak value of the current including the DC component during the first cycle after the contacts of the circuit breaker are closed is known as the making capacity. Thus the making current is the maximum value of the asymmetrical current. Now short time ratings. Sometimes the fault is of the temporary nature and is clear automatically within the 1 or 2 seconds. For example, some conducting objects falls on the overhead line conductors and falls down immediately. Circuit breaker is not tripped in this short time. The circuit breaker trips when this period is completed, so the context of the circuit breaker should be capable of withstanding fault current for certain time. Short time rating of the circuit breaker depend upon the two factors. First is capability to withstand the electromagnetic force, and second is capability to withstand the temperature rise. The specified short time ratings of the circuit breaker of 3 seconds when the ratio of the symmetrical breaking current and retained current is up to 40. But when the ratio exceeds 40, then the short time rating is of 1 second. The RMS current, number of poles, rated RMS voltage and rated frequency, rated operating duty are also is important factor of the circuit breakers. Now, classification of circuit breaker based on voltages, based on locations and based on medium use or arc quenching. Based on voltage, low voltage circuit breaker, medium voltage circuit breaker up to 1 kV to 52 kV, high voltage circuit breaker 66 kV to 220 kV, extra high voltage circuit breaker 300 to 765 kV, and ultra high voltage circuit breaker greater than 765 kV. Based on location, indoor and outdoor. Indoor is a gas insulated, outdoor type air insulated. Low and medium voltage switch gear and high voltage gas insulated switch gear are categorized as indoor switch gear, where the switch gear which have air as an external insulating medium and AIS means air insulated switch gear are categorized as outdoor switch gear. Based on medium use for arc quenching, air brake circuit breaker, oil circuit breaker, air blast circuit breaker, sulfur hexafluoride circuit breaker, and vacuum circuit breaker. Now, types of test performed on high voltage AC circuit breaker: development test, type test, routine test, and commissioning test. And maintenance of circuit breaker, failure of circuit breaker, and troubleshooting of circuit breaker. Types of test performed on high voltage AC circuit breaker: development test, type test, routine test, and commissioning test. In development test, such tests are performed during the development of circuit breaker. These tests are performed on the some component, some assembly, etc. These tests are performed to know the effect of change in parameter of component. Development tests are not included in the standards. Type test. Such tests are performed on some prototypes so that its capability and characteristics can be confirmed. These tests are not performed on all the circuit breakers. These tests are performed in special testing laboratory and performed as per IS. Uh, After the test, the circuit breaker is not used without overhauling. Then routine tests. Routine tests are performed as per IS at the manufacturer premises to check the operations of the circuit breaker. Then commissioning test. These tests are performed after the circuit breaker is installed and before put it into the services. In the type test, the tests are no load mechanical operation test, mechanical performance, temperaturized test, dielectric test, short time current test, short circuit breaking and making basic short circuit test, line charging current breaking test, cable charging current breaking test, single capacitor bank current breaking, small inductive current breaking test, out of phase switching, short line fault test are the types of the circuit breakers. Routine test. Routine tests are performed on each circuit breaker before dispatch. Mechanical operation test, contact travel, characteristic timing, millivolt drop test, measurement of resistance, power frequency voltage test at the manufacturer premises, and voltage test on the auxiliary circuits. Now, maintenance of circuit breakers. In maintenance of oil circuit breaker, there are periodic maintenance inspections in ordinary conditions. During the periodic checkup, internal and external inspections should be done after the fault when the circuit breaker is isolated. Post fault maintenance of circuit breaker like cleaning, context of arc control devices, mechanisms, insulation resistance, insulating oils, joints and seal, and step of the maintenance of minimum oil circuit breaker are quarterly, half yearly, and yearly. Now, maintenance of air circuit breaker. It's checked during the routine maintenance like operational checks, visual inspections, cleaning, insulations, circuit breaker enclosure, main and arcing contacts, air control devices, mechanisms, auxiliary switches indicating devices and interlocking, isolating contacts, overload devices, and protective relay, instrument and protective transformer, control relay or contactors, main connections, etc. are the regularly routine maintenance in and maintenance of air circuit breaker. Maintenance of air blast circuit breaker. It's also operational checks, general inspections, cleaning, conditioning of air, insulations, load control kiosk, pressure gauge, pressure switches, main connections, secondary wiring and fuses, linkage of the interpol, main mechanisms, auxiliary switches indicating device and interlock, sequence isolator, local air receiver and pressure vessel, interpreter, isolating switches, earth connections, etc. are the points of maintenance of air blast circuit breaker. Then sub-6 circuit breaker. Properties of sub-6 circuit breaker is toxicity, air, arc products, physical properties, dielectric strain, air arc quenchings, electric arc breakdown. And handling of faulted sub-6 gas. The toxicity is faulted sub-6 gas and solid arc produce. In clothing and safety equipments, coveralls, hoods, gloves, belts, safety glasses, respirator, etc. Now, uh, maintenance of vacuum circuit breaker. The steps of maintenance of vacuum circuit breaker are operational checks, general inspections, cleaning, opening devices, insulations, circuit breaker enclosure, main connection, secondary wiring and fuses, mechanism, auxiliary switches indicating devices, shutter, switchgear, spot, isolating contact, vacuum interpreter, isolating and earthing switchgear, earth connections, overload devices and relay, instrument protective transformers, control relay of contactors, etc. are the important steps in maintenance while in vacuum circuits breaker. Now, failure of circuit breaker. The possibility of failure of equipment is less when regular maintenance is carried out but cannot be neglected. Similarly, in circuit breaker, regular maintenance of mechanism, insulation, switching medium is carried out regularly even though it sometimes fails to operate. Causes of failure of circuit breaker: failure of operating mechanism, failure of dielectric, dirty quenching medium, contacts throughoutly burnt, internal flashover, leakage of the quenching medium, reptile, loss of components, a sluggish contact travel, and high value of transient recovery voltage. Now, troubleshootings in circuit breaker. Troubleshooting in circuit breaker, possible causes and remedies and measures are: first is less insulation resistance less than 2000 mega ohm. Then possible causes is presence of moisture, contaminated surface of contaminated oil, carbon particles have accumulated over the internal surface, and its remedies measures are: pass hot air or oil for 4 to 6 hours through insulations, the poles of breaker. Second one is increased resistance across the pole terminals. Its possible cause: reduced contact pressures, loose screw or bolt of the flange, contact surface might have worn out due to the frequency operations, less wipe of the contact depositions of oxidations on the terminal. And its remedies measures are: dismantle, clean and join, replace the contacts if necessary. Next is unequal wipe and contact travel where the breaker is open or the breaker is closed. Its possible causes is erosions of contacts due to frequent short circuit operations, wrong adjustment during maintenance. Its remedies measures are: check the contact strip, replace the contact if necessary, adjust the contacts if the length is unequal. Next is one pole does not close. Link of the pole might have broken, the contact of the dead pole has damaged much. Then remedies are: isolate the pole and carry out the repairs. Next is more time taken in opening. Increased friction in pole unit, high contact grip, sluggish operations of the trip coil, increased pickup time due to reduced battery voltage. Its remedies are carry out the necessary repairs. Next is breaker does not operate by the electric signal. It's spoiled spring, open trip circuits, fault in the trip coil, spring might not be charging. If the breaker works manually, the mechanism is okay. Then remedies is check the closing spring, take the suitable measures after deciding the causes, and check the supply of the spring charging motors. So these are the different types of this troubleshooting of the circuit breaker. Now, different types and routine test. First is different type and routine test, DC resistance measurement test, millivolt drop test, and mechanical endurance test. Now, different types of routine tests in uh, equipment necessary to such testing like a ultraviolet recorder or UV record, oscilloscope, potentiometer. No load tests are carried out on following conditions like solenoids operated, closed solenoid energized out, but both 105% and 85% rated supply of closing coil. For spring, hydraulic, pneumatic mechanism operated, the shunt replace should operate at 85 degree and 110% of rated supply voltage. The oscillograph records are generally obtained on multi-channel ultraviolet recorder. The DC resistance measurement test, it is a very simple test. The resistance of main circuit of each pole is very small in a few micro ohm. The resistance is directly measured by sensitive micro ohm meter. The ohm meter two test terminals are directly connected to the two terminals of the pole, and the reading of ohm meter is DC resistance of the circuit breaker pole. This is generally exactly same for all the three poles. Millivolt drop test. A suitable value of current more than 100 ampere is passed and the millivolt drop across the pole terminal is measured by the sensitive millivolt. The test is replaced for different value of current. The average value of resistance is worked out from these readings. The resistance is very small, like micro ohm. The mechanical endurance test on circuit breaker to check make and break operations of mechanical arrangement and to prove the adequate to design and manufacture. Its equipments require a circuit breaker under test, tripping circuits, lubricating system, mechanical operation facility, and relays. The procedure of the mechanical endurance test: small capacity circuit breakers needs voltage and current in the circuits. However, HVAC circuit breakers need no voltage or current in testing in the main circuit. In mechanically testing, circuit breaker is open and closed so many times, even up to 1000 times. Some 50 operations are activated by energizing relay. Remaining operations are by doing the trip circuit by other means. About 100 operations are made of connecting the main circuit in series with the trip circuit. Manufacturer may be doing more than 1000 operations. Ascertain the mechanical healthiness of design and its quality. Modern circuit breaker and SF6 circuit breakers are practically maintenance free. So these are the mechanical engines test. Now, next is lightning arrestor. The types of lightning arrestor are rod arrestor, horn gap arrestor, multi-gap arrestor, explosion type lightning arrestor, valve type lightning arrestor, silicon carbide arrestor, and metal oxide arrestor. Now, rod gap arrestor. The device is used for this called lighting arrestor or the surge diverter. Lighting arrestor is kept at a suitable place in the substation. It is connected between the line and earth. In normal conditions, the air gap is sufficient for the line voltage, so the current does not flow to the earth through the diverter. But when the traveling wave comes on the line and the diverter and reaches to some voltages, the breakdown of air gap occurs and the arc is produced, so the diverter gives the impedance path. Now, rod gap arrestor. This type of lighting arrestor has a simple construction. Two rods of 15 mm diameter are bent at right angle and kept such that some gap remains between the two rods. One rod is jointed to the line conductor and the other rod is jointed to the ground. The distance P between the insulator and gap should be more than the 1/3 of the length, so the arc occurs away from the insulator when the arc occurs. The length of the gap is kept such that the breakdown occurs at 80% of the spark over voltage so that the slip wave front does not come on the insulator. Now, sphere gap arrestor. In these two metal spheres are kept near to each other at certain small distance. Sphere A is sphere A is connected to the line and sphere B is connected to earth. One choke coil is connected between the phases B of the transformer and sphere A so that the overvoltage surge does not go to winding of the transformer after reflection. There is no discharge at normal voltage in the healthy conditions. The air between the spheres breaks down and the arc is produced between the spheres. When the overvoltage comes, the arc goes up due to the heat. Arc continues at the normal voltage and it stops when the voltage is not available when the circuit breaker is tripped. Now, horn gap arrestor. These are horn shaped metal rods. One is connected to the line and the other is earth. There is an air gap between the two. The horn are mounted on the porcelain insulators. In the healthy conditions at normal voltage, no arc is produced between the two horns. Arc is produced across the horns due to the lightning. So the overvoltage surge is grounded due to the heated air. The arc goes upward. Its length is increased and the arc is quenched. An inductor is connected between the winding of the transformer and the horn, which gives negligible reactance at the power frequency but offer high reactance to the overvoltage due to its high frequency. So the overvoltage does not affect the winding of the transformer and is grounded through the horn gap. Resistance is connected in series with the horn to limit the follow current. Now, locations of lightning arrestors with reasons. The lighting arrestor are installed in following locations. Like first is surge arrestor are connected to the incoming lines at the substation, protected against the traveling waves on the line due to lightning. It discharges lightning over voltage and switching over voltage to the earth. Surge arrestor or lighting arrestors are also connected to the bus bar of the substation to protect the bus zone from direct lightning shock. Near terminals on HV sides of each transformer between phase and earth. Near LV side of each transformer between the phase and earth. Between transformer, neutral and earth. Between tertiary terminal and earth for each phase of safety tertiary winding of the transformer. Across the phase to phase for delta connected transformer winding. Here in these tables, uh, first connections description rated voltage is arrestor connected between phase to phase and earth. Okay, Vn greater than equal to Vm. V1 is a rated voltage at arrestors. Vm is a maximum phase system voltage. Second is arrestors connected between transformer and neutral and earth. V1 greater than equal to 0.8 volt Vm. Next is arrestor connected in delta between phases. Next is arrestor connected between phase and ground to protect the tertiary winding, means V1 greater than equal to Vm. And fifth is arrest connected between phases and ground near terminals of rotating machines. So these are the different types of connections of surge arrestor. Okay, thank you. The surge arrestor are connected to the incoming line at substation protection against the different time-varying waves on the line due to the lightning. It discharges lightning over voltage and switching over voltage to the earth. The surge arrestor or lighting arrestors is also connected to bus bars of substation to protect the bus zone from direct lightning strokes. Near terminals on high voltage sides of each transformers between phases and the earth. Near low voltage side of each transformer between the phase and earth. Between the transformer and neutral and earth is the between tertiary terminal and earth for each phase of tertiary winding of the transformer, and across the phase to phase for delta connected transformer windings. So these are the uh, lighting arrestors are installed in these following locations. Once again, thank you so much.